suddenly something changes. The stars ahead of you begin to stretch like rubber bands. Colors distort. Time itself feels slower. You don't feel a pull. You don't feel a force. But the universe around you is bending, as if an invisible hand is rewriting reality. You're approaching something so powerful it can freeze time, swallow light, shred atoms, and break the very rules that hold the universe together. This is a black hole, the closest thing to magic that physics has ever found. And today, we're going to step into its darkness to discover what black holes are, how they form, what happens if you fall inside, and why these monsters might shape the future of science. Let's begin. But not too close. They sound like science fiction, but they are very real, scattered across the universe like cosmic landmines. Invisible, silent, and endlessly mysterious. To understand them, we start with something familiar. A star, but not a gentle, friendly star like our sun. We need a giant, a star 10, 20, or even 50 times more massive. For millions of years, this enormous star burns hydrogen, creating an outward pressure that keeps gravity in check. You can imagine it like a cosmic tug-of-war. Gravity pulling inward, fusion pushing outward. And for a long time, everything stays in balance, but eventually the fuel runs out. Without that outward pressure, gravity wins instantly. The star collapses, its core squeezing tighter and tighter until the atoms inside it break apart. Electrons merge with protons, protons crush into neutrons, and even neutrons start giving up. The collapse becomes unstoppable. Then, boom, a supernova. One of the brightest, deadliest, most powerful explosions in the universe. For a few moments, the dying star shines brighter than entire galaxies. And at the center of the explosion is what remains of the core. A tiny, dense, almost unimaginable object. If the core is heavy enough, its gravity becomes so extreme that it collapses all the way down to a single point of infinite density. This point is called a singularity, and the region around it becomes what we call a black hole. A black hole is not a hole or a tunnel or a giant vacuum cleaner. It's a region of space where gravity is so intense that nothing, not even light, can escape. The boundary around it is called the event horizon. Cross it, and you're gone forever. No message can escape, no light can escape, no information can escape. It is the ultimate point of no return. From far away, a black hole looks harmless, invisible, silent, like a blank patch of space. But as you get closer, the universe begins to behave strangely. Light bends, time stretches, space becomes distorted. If your friend watched you fall toward a black hole, you would appear to slow down, freeze, and slowly fade from existence, never crossing the horizon. But from your own perspective, you fall straight in. Time continues normally for you, but the rest of the universe seems to speed up. Seconds turning to years, years to thousands of years. This isn't imagination. It's physics. Black holes literally warp space-time. The closer you get to the singularity, the stronger gravity becomes. Not just strong, but uneven. Your feet feel more gravity than your head. Your atoms are pulled in different directions. This extreme difference stretches your body longer, and longer, and longer, until you become a thin, noodle-shaped strand of atoms. Scientists actually call this process spaghettification. It sounds funny, but it's one of the most violent forces in the universe. Your atoms would tear apart, your molecules would rip, and everything that makes you vanishes in seconds. Fortunately, you'd never be conscious long enough to experience this nightmare. Black holes formed from dying stars are small compared to the monsters hiding in the centers of galaxies. These giants are called supermassive black holes, and they weigh millions or billions of times more than the sun. Nearly every galaxy, including our own Milky Way, has one at its center. Ours is called Sagittarius A. It contains the mass of about 4 million suns compressed into a space smaller than our solar system. And here's the surprising part. These supermassive black holes help galaxies form and stay stable. They control the movement of stars, shape the structure of spiral arms, and regulate how galaxies grow. Black holes don't just destroy, they organize the universe. Black holes don't roam the galaxy like space monsters. They don't suck stars like vacuum cleaners. Most black holes are calm and quiet. If our sun became a black hole, without changing its mass, Earth would keep orbiting exactly the same way, though it would be cold and dark. Nothing gets swallowed unless it gets too close. Black holes are dangerous because of proximity. not hunger. For decades, scientists believed black holes live forever, but Stephen Hawking changed everything when he discovered Hawking radiation. Empty space isn't truly empty. It's full of tiny virtual particles popping in and out of existence. Near a black hole's horizon, one particle falls in and the other escapes. To the universe, it looks like the black hole is losing energy. Over trillions of years, a black hole slowly evaporates, shrinks, and eventually disappears. The most powerful objects in the universe end not with an explosion but with a whisper. This is the greatest question in astrophysics, and the one we still cannot answer. Inside a black hole, the laws of physics stop making sense. Time and space become tangled. Matter becomes something we cannot describe. The singularity is a place where our equations break. Some scientists believe a black hole's center might be a bridge to another universe. Others think it contains new dimensions. Some say information goes somewhere else, into a different region of space-time. Others argue the singularity isn't a point at all, but an unknown quantum object. Black holes are the boundary between what we know and what we don't. To understand them, we must combine two giant theories. Black holes are not just cosmic monsters. They are reminders of how vast, strange, and beautiful the universe truly is. They bend space, slow time, form galaxies, and challenge everything we know about physics. They are both creators and destroyers, gatekeepers of cosmic mysteries waiting for us to unlock. And until we understand them, we continue doing what humans do best, asking questions, exploring the unknown, and pushing our curiosity farther and farther. Because curiosity is the one force in the universe no black hole can ever swallow.